We now discuss the solution of a problem from the section Coordinate Geometry. This problem is on a given parametric curve. This question has appeared in the Joint Entrance Examination Main held on 25th June 2022 in the second shift. The given question is, if the angle made by the tangent at the point x0, y0 on the curve x is equal to 12 multiplied by t plus sin t cos t, y is equal to 12 multiplied by 1 plus sin t whole square, where 0 less than t less than pi by 2 with the positive x-axis is pi by 3. That is, the angle made by the tangent at this point x0, y0 on this curve, which is whose parametric representation given by this, with the positive x-axis is pi by 3, then we have to find the value of y0. We are given 4 options. Option A, 6 multiplied by 3 plus 2 root 2. Option B, 3 multiplied by 7 plus 4 root 3. Option C, 27. Option D, 48. We now discuss the solution of the problem in detail. We are given the parametric representation of the curve. The curve is represented by C. The parametric representation is x is equal to 12 times t plus sin t cos t, y is equal to 12 times 1 plus sin t whole square, where the parameter t belongs to the open interval 0 to pi by 2. That is 0 less than t less than pi by 2. We are given the angle made by the tangent to this curve at the point x0, y0 on C with the positive x-axis is pi by 3. So we have a curve C at x0, y0. Now the tangent is drawn. That tangent is making an angle pi by 3, theta is equal to pi by 3 with the positive direction of the x-axis. So here theta is pi by 3. This means the slope of the curve C at x0, y0 is tan pi by 3. Correct. How do we give the slope for a parametric curve? We take dy by dx at x0, y0, that is equal to tan pi by 3, that is the slope at x0, y0. Tan pi by 3 is root 3. But our curve is given through parameters, that is, it has a parametric representation. So dy by dx is computed as dy by dt by dx by dt. That is parametric differentiation. Before that, let us take x0 is equal to the value of x at t0, where t0 is the parameter corresponding to x0, y0 is equal to y at t0. Agreed. Now dy by dx is equal to the parametric differentiation dy by dt by dx by dt. Dy by dt is 12 multiplied by the derivative of t. Dy by dt, y is 12 times 1 plus sin t whole square. Dy by dt is 12 into 2 into 1 plus sin t. The derivative of 1 plus sin t with respect to t is cos t by dx by dt, that is 12. Derivative of t is 1. Derivative of sin t cos t, we have written this as 1 by 2 sin 2t, and on differentiation it is cos 2t. Now 12 cancels, and we will get 2 times 1 plus sin t cos t by 1 plus cos 2t. 1 plus cos 2t we have written it as 2 times cos square t. Now cancel cos t, both numerator and denominator. We need not worry because t is equal to pi by 2 is not there in the domain of definition of the parameter t. T lies between 0 less than, t less than pi by 2. So t is not equal to pi by 2. Therefore we can cancel cos t. 1 plus sin t by cos t, that is dy by dx. So from 1, dy by dx at x naught y naught, that is dy by dx at x naught y naught means when t is equal to t naught, that is equal to root 3. That is from the equation 1. That implies 1 plus sin t naught by cos t naught is equal to root 3. We continue in the next slide. So that is the story so far. Dy by dx at t is equal to t naught is equal to 1 plus sin t naught by cos t naught is equal to root 3. Cross multiply and then rearrange the terms. Then we get root 3 cos t naught minus sin t naught is equal to 1. Now divide throughout by under the square root of the coefficient of the square of the coefficient of cos t naught, that is root 3 whole square, and the square of the coefficient of sin t naught, that is minus 1 whole square, that is 1 by under the square root of root 3 whole square plus minus 1 whole square, that is 1 by 2. So multiply throughout by 1 by 2, we get root 3 by 2 cos t naught minus 1 by 2 sin t naught is equal to 1 by 2. This is written as cos t naught for root 3 cos pi by 6, right, minus sin t naught into, for half we have written sin pi by 6. This is cos A cos B minus sin A sin B, that is cos of A plus B, that is cos of t naught plus pi by 6 is equal to 1 by 2. So t naught plus pi by 6 is equal to cos inverse 1 by 2. What is cos inverse 1 by 2 in the interval 0 to pi by 2? 0 less than t less than pi by 2, cos inverse 1 by 2 is pi by 3. That is t naught plus pi by 6 is pi by 3. So t naught is equal to pi by 3 minus pi by 6, that is pi by 6. Now we got t naught, and what is that we want? We want y naught. What is y naught? Y, the value of y at t naught. What is t naught? It is pi by 6. So y at t naught is equal to 12 times 1 plus sin t at t is equal to t naught, sin t naught whole square. That is 12 into 1 plus sin t naught is sin pi by 6. And sin pi by 6 is 1 by 2. So 12 into 1 plus 1 by 2 whole square, that is 12 into 3 by 2 whole square, that is 12 into 9 by 4. So when simplified, we get 27. That is the value of y naught. That's what we wanted to find in the question. Now let's look at our options. Our answer 27 appears against option C. Therefore, the answer for this question is option C. That is the detailed discussion of the solution of a problem on a given parametric curve. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.